The human brain is one of the smartest on the planet, capable of solving problems that no other species on this planet can. It's also among one of the most complex and unsolved mysteries that exist today. With over 100 billion neutrons, it is more powerful than any other machine that has ever existed. But there are still some things we just can't wrap our minds around, and the most prominent of them are paradoxes. We've evolved to think of reality in a certain way, yet there are certain paradoxes that imply reality doesn't function the way we believe it does. While studying physics, we might have come across a lot of these paradoxes that are strange and mind-bending. But what are the strangest paradoxes that exist? Let's take a look at the 7 most strange and mind-boggling paradoxes in physics. Number 7. The Fermi Paradox. When you look at the dark night sky and stare into the vastness of space, you're only looking at our local neighborhood and at the very best about 2,500 stars. The universe is way bigger and has billions and billions of galaxies. Each galaxy approximately has 200 billion stars in them and thus trillions of planets in each galaxy. This leaves us with 500 billion sun-like stars in our universe and 100 billion Earth-like habitable planets. That's quite a big number to imagine. Earth formed around 4.5 billion years ago and developed life approximately 3.5 billion years ago. Using this, we can speculate that even if 1% of all the Earth-like planets go on to develop life and become intelligent, we have 100 billion intelligent civilizations in the observable universe. Using this estimate, there would be 1 billion Earth-like habitable planets in our galaxy and 100,000 potential intelligent civilizations that might exist. Quite shocking, right? If 100 billion intelligent civilizations exist, shouldn't the universe be teeming with spaceships? Where are all the aliens? The question remains now that we know how many worlds there are and how many advanced civilizations there may be. Why is the universe deafeningly quiet? This is the Fermi Paradox, and no one has an answer to it. All we have are possible theories about them. We have also made a full video on all of these possibilities of Fermi Paradox, so make sure to watch it to know more. The link is in the description below. Perhaps we'll find out about aliens soon as technology progresses, or perhaps we've already been visited by some other civilization and don't know it. Recently, there have been several inexplicable UFO sightings, and some believe extraterrestrials have already arrived. This paradox would be resolved if there was solid confirmation of that. Number 6. The Bootstrap Paradox. The Bootstrap Paradox is a paradox of time travel. It is a common theme that is used by writers in many sci-fi novels and films. Netflix's Dark was one such mind-bending show. Let's look at an example of the Bootstrap Paradox. Imagine a young boy named Albert, who, like you, is a big fan of physics and has always longed to meet Albert Einstein. Now he creates a time machine with the world's top brains, and one night he sneaks into the laboratory and uses the time machine to travel back in time to see Albert Einstein. When he arrives, he discovers that no Albert Einstein ever lived, and that no one had ever heard of Albert Einstein. He feels sorry for him, but he has a notebook with all of Albert Einstein's ideas and equations. He creates and publishes a book under the name of Albert Einstein, and yay, he becomes renowned. And he is now and has always been known as the Albert Einstein. How is it even possible? Without Albert Einstein, he would not have been able to become a scientist, and without him, there would have been no Albert Einstein who ever existed. This results in a time loop that will continue indefinitely. The Bootstrap Paradox contradicts our concept of time. An event A in the past creates an event B in the present, which produces an event C in the future. However, in the past, it was event C that created event A. This contradicts our understanding of time and does not match with our linear explanation of time. The question becomes who actually wrote all of Einstein's equations. Number 5. The Grandfather Paradox. The Grandfather Paradox is another time travel paradox. In the Grandfather Paradox, you travel back in time to wipe out your grandfather, by which we mean erase his existence. We all know how much everyone here adores their grandparents, but this is only one example. You are a time traveler once more, and you go back in time to commit the job and erase your grandfather's existence. You then return to the present, but because your grandfather is no longer alive, your father was never born, and you now understand you never existed at all. Everything about you has been deleted, including your family, friends, belongings, and past. So you wouldn't have been born in the first place, making this impossible. According to some experts, if this occurred, you would have created an alternate timeline or perhaps entered a parallel universe. Would you exist or not? Number 4. Schrodinger's Cat Paradox. The Schrodinger's cat example is something very strange that all of us might have heard about before. Schrodinger proposed this thought experiment in 1935. The paradox depicts a cat trapped within a windowless box containing radioactive material, a Geiger detector, a hammer, and a jug of lethal poison. The radioactive material has a 50% chance to decay. If the Geiger counter detects an emitted radioactive particle, it activates a hammer, which smashes a container of poison that will kill the cat. You wouldn't know if the cat was alive or dead until you opened the box. As a result, until the box was opened, the cat would be both alive and dead, because the fate of the cat depends on whether the radioactive material has decayed or not, and the cat, as Schrodinger puts it, would be living or dead in equal parts. The state of the cat would be completely unknown until the box is opened. In other words, the cat would be in superposition of both states. Schrodinger created the paradox to demonstrate a point in quantum physics concerning the nature of wave particles. The double-slit experiment is another fine example of this paradox. Number 3. The black hole information paradox. Black holes have puzzled the human brain ever since they were first discovered. They are mostly known for devouring all matter such that nothing, not even light, can escape it. But they too present us with a big puzzling paradox, arising from the interaction of quantum physics and general relativity. Calculations suggest that physical information might vanish into a black hole indefinitely, enabling physical states to deteriorate into the same state. However, this is debatable because quantum theory holds that information can never be destroyed. Assume you destroyed 2 separate letters written on paper. Putting them back together from ash would be difficult but not impossible. Even little changes in smoke, temperature, and ash content would preserve information about the 2 separate letters. The problem with black holes is that they suck things up and then, after a very long time, radiate what they have swallowed back out as Hawking radiation. Unlike the smoke, temperature, and ash produced by the burning of a letter, Hawking radiation carries no information about what the black hole ate. This is due to the fact that all Hawking radiation is the same, implying that black holes annihilate knowledge about the universe. So, do dissolving black holes destroy information, or does it escape when the black hole evaporates? A new group of scientists claims that information does actually escape a black hole via its radiation, and they have discovered the quantum extremal surface, an unseen surface that exists inside a black hole's event horizon. This surface appears to encode the quantity of information that has radiated away from the black hole, changing exactly as predicted over the black hole's lifetime if information escapes. Number 2. The simulation paradox. Is reality real? What if the reality that we perceive is actually a very advanced computer program? These questions of the simulation argument will make your brain hurt. Many sci-fi novels and movies like The Matrix have depicted the idea of us living in a simulation. The idea of us living in a simulation has been around for a long time, but ever since Nick Bostrom of the University of Oxford published a fundamental paper on the simulation argument in 2003, philosophers, physicists, technologists, and yes, comedians have wrestled with the concept that our world is a simulation. In 2003, Bostrom envisioned a technologically advanced society with enormous processing power and just a portion of that capacity required to simulate new worlds with conscious creatures. Given this circumstance, his simulation argument demonstrated that at least one of the following trilemma propositions must be true. First, humans nearly usually become extinct before reaching the simulation-savvy stage. Second, even if humans reach that point, they are unlikely to be interested in recreating their own ancestors. Finally, the likelihood that we are living in a simulation is close to 1. Many scientists disagree and might call this pseudoscience, but the simulation argument is quite convincing for many. Maybe what we call God might be the technologically advanced civilization that is controlling our simulation. What is the correct answer to the simulation argument? Knowing the answer to this question might come down to advanced AI research in the coming future. Number 1. Unifying quantum mechanics and general relativity. You wouldn't have heard much about this particular paradox anywhere else. The stakes cannot get any higher. There isn't a bigger problem in physics to ever exist than the problem of unifying quantum mechanics with general relativity. This is the problem physicists have spent decades on. General relativity and quantum mechanics are two fundamental pillars of modern physics. General relativity is a theory explaining the universe on the largest of scales. For example, black holes, galaxies, neutron stars, etc. It elegantly accounts for gravity and all it governs, circling planets, colliding galaxies, and the dynamics of the expanding universe as a whole. On the other hand, quantum mechanics describes the universe on the smallest of scales. It is in charge of the other three forces, electromagnetism and the two nuclear forces. Quantum theory is quite good at describing what occurs when a uranium atom decays or when individual light particles strike a solar cell. Years of investigation have resulted in physicists empirically confirming nearly all predictions made by each of these theories with near impossible precision. However, these same theoretical tools inexorably lead to another troubling conclusion. General relativity and quantum mechanics cannot both be correct as they are now articulated. The two hypotheses that have underpinned the extraordinary progress in physics over the last century, progress that has explained the expansion of the heavens and the fundamental structure of matter, are mutually incompatible. This is very strange. How can two perfectly fine theories in physics be mutually incompatible? For more than 50 years, physicists have tried to unify these theories, but they haven't been successful. A recent hope has been the string theory, which promises to unify both of these fundamental pillars of physics. Intense study by physicists and mathematicians from all around the world over the last decade has revealed that this new way of defining matter at its most fundamental level overcomes the contradiction between general relativity and quantum mechanics. In fact, superstring theory reveals far more. Within this new framework, general relativity and quantum mechanics require one another for the theory to make sense. There is much skepticism surrounding string theory, as it is only theoretical for now, but it is our best hope today. The future will tell us whether it will be successful in unifying both of the fundamental laws of physics or not. So what do you think about these paradoxes? Which is the strangest one for you? Let us know what you think in the comment section below. More updates about these paradoxes will be coming in the future, so make sure to subscribe to our channel and press the bell icon to be notified of all the latest developments regarding these strange paradoxes.